All right, here we are. This is stage 2. Basically everything up here, I'm not very good at scribbling very dramatically, so I have to shorter strokes and shorter brush strokes there. Stage 2, we're going to start out with glyceraldehyde-3-phosphate. We're going to have 2 identical molecules of glyceraldehyde-3-phosphate. We're going to have 2 identical, basically, copies of this sequence going on. Now, our first enzyme is going to be where we produce our first NADH molecule. Keeping in mind that this is happening 2 times, we've got glyceraldehyde-3-phosphate, NAD+, and then we're going to produce 2 NADH molecules and 2 identical molecules of 1,3-bis-phosphoglycerate. So what we did here was we put a phosphate group. We took our inorganic phosphate and we were able to add that on right here onto carbon number 1. So carbon number 1 and carbon number 3 both have a phosphate group on it. So 1,3-bis-phosphoglycerate. We've got 2 copies of this. Now our next enzyme is going to be where we get some of our payback. So in stage 1, that was our investment phase where we were putting ATP in. Phase 2 or stage 2, now we're going to be getting some of the return. So what we did, or what we now are going to use, is the enzyme known as phosphoglycerate kinase. Phosphoglycerate kinase is going to take 1,3-bis-phosphoglycerate right here, and it's going to pick the phosphate group off of carbon number 1. Now this is known as substrate level phosphorylation. What this is going to be is taking ADP, 1,3-bis-phosphoglycerate, and producing an ATP molecule. Keeping in mind that this is taking place 2 times, we've got 2 ATP molecules that are generated off of this. Now, if you think back to our initial stage 1, we invested 2 ATP. Here, we've got 2 ATP back. So basically, at this stage in time, energetically, or ATP investment-wise, we've gotten a return on what we initially invested. Now, the product that's going to result from this is a molecule known as 3-phosphoglycerate. How different do you think that is from this molecule right here? Well, we got rid of the phosphate group on carbon number 1. Other than that, it's the same. Now, 3-phosphoglycerate is going to be the substrate for the molecule known as, or the enzyme known as phosphoglycerate kinase. Now that phosphoglycerate kinase is going to take I mixed that up. Not phosphoglycerate kinase, phosphoglycerate mutase. That's going to take our 3-phosphoglycerate, and this is essentially a isomerase. What it's going to do is it's going to take the 3-phosphoglycerate and rearrange our phosphate group that's on carbon number 3 and put it on carbon number 2. So here's what that's going to look like. We take our 3-phosphoglycerate and boom, just pushes that phosphate group from carbon number 3 onto carbon number 2. So that's all that this consists of. This is an interconversion of 3 to 2 positioning of that phosphate group there. Now, the result of that is going to be the enzyme known as Enolase is going to take our 2-phosphoglycerate molecule, and it's going to produce or release a proton and release a hydroxide group, and in that, or through that process, we're going to make phosphoenol pyruvate. So that phosphoenol pyruvate has striking similarities to our pyruvate, which is our last step in this process, but it still has a phosphate group on it. The last step, ultimately, is to remove that phosphate group. So this is where we're actually getting kind of the profit, I guess you could say, of ATP. So with the enzyme pyruvate kinase, we took PEP, phosphoenol pyruvate, ADP, we're going to produce pyruvate, and we're going to produce ATP. All right, so here we are with our last step in stage 2 of glycolysis, and this is the synthesis of our molecule that has several different fates, and that is pyruvate. What we need to do is take this phosphorylated molecule, phosphoenol pyruvate, aka PEP, and transfer this phosphate group from PEP onto ADP and produce ATP. So what this means is that we've got this taking place 2 times simultaneously. Not 2 times simultaneously, but we've got it taking place simultaneously where 2 different enzymes of pyruvate kinase are producing pyruvate and they are producing ATP. This would be an instance of substrate level phosphorylation where we have kind of our profit of ATP. If you remember stage 1, we invested 2 ATP molecules. Now we're getting those back, or now we already got them back. Now we're getting more ATP back. So this is an irreversible step. This is arguably our final step because this pyruvate can go in 3 different directions. It's got homolactic fermentation, we've got our alcoholic fermentation, or the citric acid cycle. All right, I hope this is helpful, and I will see you in the next. Oh wait, never mind. There's a little bit more. This is our overview of everything that we covered. This is your overall reaction. We took 1 glucose molecule, got 2 pyruvates, and a bunch of other stuff. But that's essentially our summary. All right, have a good